Namaskar, welcome back. So today we will discuss and probably in coming few lectures about uh, the signatures of ongoing deformation and also ancient deformation, what we call the paleo deformation or paleo earthquake related features. Okay. So before this lecture, we had discussion on the methodology part. Keeping that in mind, we will uh, continue learning about the landforms, okay, mainly. So, in this, we will be looking at two types of landforms mainly, that is fluvial and coastal. Okay, glacial landforms are also important, but mostly, but they are because not many people are been affected uh, due to earthquake in that region. So we are not going to cover that part. Nevertheless, earthquakes can trigger avalanches and can be dangerous and disastrous, but not many people will be getting affected. And most of the studies which have been done looking for the geomorphic markers and signatures of paleo earthquakes are mostly in the fluvial landscape and also the coastal landscape where we see uh, the uplifted coastlines, and also we try to see the signatures in coastal stratigraphy, near shore coastal stratigraphy. At the same time, even the fluvial deposits can indicate. Uh, so we are right now we are talking about the geomorphology, so morphology of the surface, but stratigraphically also the sections. If you see where the sediment record is there, that can also tell you some uh, story about the past events. Okay, how the landscape evolved, and it was purely due to tectonic or purely due to climate change and all that. However, it is a bit difficult to decouple the climate and tectonics, but to some extent, people have tried and got success in differentiating uh, the signatures or the evidence related to the tectonic influence and climatic influence. So let's move ahead on this. So mostly what we try to look at is the signatures of paleo earthquakes, and in general term, if you take geomorphology, then that talks about the study of surface features of the earth carved by river, wind, glacial of the ongoing deformation in the plains and basins also. Okay. So, crustal deformation and mountain building activity, we have learned and discussed about the mountain building activity, uh, or we can say the large scale landforms in plate tectonics, where we talked about the Himalayas and all that. So, this is the photograph from of higher Himalayas from Kangra Valley. So, the Earth's surface in action, mountain uplift, global cooling. So, this just I am giving an example that how the mountain building activity can also have effect on the climate change. So, tectonics or ongoing deformation or deformation which is going on since past geological time period can affect the climate also. Nevertheless, the best example is your Himalayas, which gave us a different season, monsoon mainly, and also the mighty rivers, and at the same time we got the alluvial plains, fertile land in the frontal part of the Himalayas, that is your Indo-Gangetic plains. So, active mountain building process is linked to global climate change, through airflow modification and in part through weathering. So, weathering, what we see is mainly the weathering erosion which is going on in the Himalayan region. Young mountains, and of course, Himalaya is very young mountains, and so young mountains weather and erode very quickly. Weathering process remove carbon dioxide from the atmosphere by converting it to soluble carbonates. So you are linking this with the precipitation and all that. Okay. The carbonates are carried to the ocean where they are deposited and buried. Further, it is possible that growth of Himalaya scrubbed enough carbon dioxide from the atmosphere to cause a global climatic cooling process that culminate the quaternary ice age. So this is related to the quaternary ice age also, and but you can think of that if erosion is very fast can result into the cooling phase in the region. Okay. So this is one of the what we are talking about, the carbon dioxide, how it will get into the oceans and how it will be more and more it will be removed from the even from the atmosphere. Now, straight away we will go to the fluvial uh, landforms where we'll learn about the channel pattern and the associated landforms and how why we want to learn this actually because uh, you need to differentiate between the tectonic uh, 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 signatures or tectonic activities which have affected the channel pattern or the fluvial landform, and and that can be differentiated from the normal processes. So that part is so that is the reason why this part is important. Now, starting with the formation of the drainage basin, usually we see that if you have a slope and you have a precipitation, then it will grow headward. Okay. So the development of the basin will be towards the headward side. So small streams, that what we call the first order streams, will keep joining and then we'll have the extension of the basin as it has been shown from here. This one, second, third, fourth, fifth stage and sixth stage. So understanding the overall basin, because wherever we see the drainage or the river system which is developed, it has uplands, it has the four-lane basin, and then finally the journey is ended to the to ocean or any major river that if it is a tributary. So river system as a whole, we talk about that running water is the most important agent of erosion on the continents, and the river valleys are most common landforms on the surface, provided we have the precipitation. Okay. Rivers flowing to ocean drain almost like 68% of the Earth's land surface. The remainder of the land is either covered by ice or drained to closed basins. Now, these rivers or the drainage have capability to gradually sculpture the land by eroding away the material in same place and depositing in another place. Now, this erosion and deposition can also be triggered by tectonics. Of course, it can be triggered or it can be influenced by climatic change also. If you have higher precipitations, then that can be done. Nowadays, what we see in India during the past couple of months during monsoon, that we have a lot of uh, streams and the channels which are over flooded and they are carrying coarser deposits and all that. So these rivers have the capability to erode and deposit. Okay. So if we look at the longitudinal profile right from its origin, that is what we call in the headwaters or uh, the uh, the uplands. Okay, and then you have finally it ends its journey. Okay, so this is the longitudinal profiles, typical longitudinal profile you will be able to see. Okay. So it goes like this. This is the contact of that. Okay, so you have this typical longitudinal profile, and what we see like in the upstream, the channel shape, or we can say, and and what we see at the uh, in the plain areas and all that, that is your floodplains. Okay, so mostly in the uplands, we'll see the flows are confined, the valleys are incised, we can say, or we cut in V shape valleys. Whereas in the floodplains, a floodplain area, the channel will be wider, and adjacently we will see the formation of the floodplains, the flat areas. Okay, and then often if the floodplains are multiple floodplains, if you see, then we call that as in terraces. We will come to that part also. Okay, so these are the two important points. One is the cross section, and one we are talking about the longitudinal profile, how it looks like. Okay, so it will be like you will see a sort of an concave shape uh, of the longitudinal profile from the origin to its where it ends its journey. Okay, and then we also have different landforms which are forming at the mouth, within the floodplains, okay, and in the uplands. Okay, so that slowly we will try to look at that. What are these landforms? Because we need to understand this, have the knowledge of the landforms, and when we try to look at that, if so there are few landforms which are not indicative of this processes, then we say that okay, fine, this could be in tectonic landforms. Okay, so river system, as we have been discussing, that it has multiple tributaries which will join the trunk stream, and that will form the higher order uh, stream or the basin. Okay, so water through surface runoff and tributaries fed into a river forms the part of drainage. Okay, so drainage basin mainly, and are separated by divide known as drainage divides. So these are the divides you have. Okay, so these are all your drainage divides. Okay, and then streams are flowing in this direction into the main stream here, and similarly you have the streams which are flowing. So this will become your sub basin. Okay, and then finally you can have this as a major basin over here. So few things we are just learning, and then we will move ahead further. Even the sediments, if you see from the upstream source to the downstream, then as I told that it will have a very typical profile uh, like this, as well as the sediments will be different in the sense we will have coarser deposits in the upstream side, that is in the uplands, as well as the steeper gradient, shallower gradients, and comparatively finer deposits and fine deposits in the close to the mouth or the alluvial plains. Okay, and then river will always try to uh, keep itself, that is its longitudinal profile if you take. So the river will always try to keep itself in the equilibrium under the influence of the base level change. So if there is say change in the sea level, then there will be change in the longitudinal profile. It will incise further. If the sea level goes high, or if there is a high sea level, rise in the sea level, then it will show a sort of an aggradation or deposition in the upstream side. So this is the part here that generally the particle size may decrease downstream, gradient decreases downstream. However, drainage carrying capacity and velocity increases downstream, it will carry more sediments. Okay. And this will be like it will be true for the areas which are having good rainfall. So the base level we will keep in mind, because this is going to be an important parameter for us to look at the tectonic landforms. So channels of like cross sectional shapes, if you see upstream to downstream side, it typically vary, and this figure, it also explains the sort of like discharge with respect to the width of the channel, with respect to the depth, with respect to the velocity, and with respect to your. So the discharge remains the common parameter, but this changes. So how it varies? So width, then you have depth, velocity, and gradient. So this what we were talking about, that we have the what is the shape of the channel, whether it is shallow or whether it is wide or narrow, deep, or we have shallow here, velocity is high or low, and then gradient steeper or gentler gradient. Okay. And what we see here, that we have a very typical gradient which is not very smooth, and of course in such regions the changes will be very effective in terms of the erosion and all that. Okay. So if you look at A, so these are the points which have been given here, that what is going to happen A, B, and C. Okay. So these are the points which have been given here, A, B, and C in all the graphs here. Okay. So if we look at if you increase the width, the discharge also increases from A, B, and C here. Okay. At the same time, if you have depth increase, so with respect to that also, it is a very similar effect as compared to what we are looking at the width. And the velocity here, of course, if you at A, and if you go to C, up to C, the velocity also increases, discharge also increases. Okay. And if you compare with the gradient, okay, then also what you see is the gradient is high here, and if you look at the discharge also increases, but the gradient decreases. Okay. At different points A, B, and C. So all if we keep this in mind and then work and try to look at the tectonic landforms, then we can easily differentiate between the tectonic and non-tectonic deformational signatures. Okay. So changes downstream, if we look at, then traveling down a typical stream from its head to mouth. Okay. So discharge increases, stream cross-sectional cross-sectional area increases, velocity increases, gradient decreases. Okay. So this is the part which we were discussing in the previous slide also, the same slide here. Okay. So these are the few points which I think I suggest you to keep in mind, because when we are discussing further, including the base level change part. Okay. Now coming to the base level, what exactly is the base level we are talking about? Okay. Now in simpler way I will explain, and that can be kept in mind. So if you have a sort of we can say the longitudinal profile like this. Okay. So any water body, or we can say if you can say the ocean also. Okay. So or the stream is flowing and meeting the major trunk stream or the major drainage. For example, we have like Ganga, and then if this stream is coming and meeting here, so this will be the if there is change in the gradient of Ganga river, okay, then this will also change, tributary also. So gradient of the tributary also will change. Okay. Second part is that this is the base level of the ocean. Okay. But now if you have a sort of streams coming from the uplands, so and then debouching onto the like plain areas. Okay. So this is your upland and this is your plain area. So for example, if we say the upland is your Himalaya and the plain is your Indo-Gangetic plain. So this portion will be your base level. That is your mountain front. This will be your base level. And as we have been learning, we will definitely talk about the faults and all that. Suppose this portion goes down and this portion gets uplifted, because we know that there is an ongoing deformation between the Indian plate and the Eurasian plate. Okay. And that is the reason why we are looking at the mountain building activity. Okay. So if suppose this portion, this is your south and this is north, and this plate is moving, the Indian plate is subducting or colliding with the Eurasian plate. This is your Eurasian plate and this is your Indian plate. Now suppose this, there is a change because this is getting uplifted. Okay. This portion is going up. Okay. Now if this is uplifted, then there will be a change in the base level. And that base level will result into an erosion. So now suppose if you take the gradient is like this is your plain areas, this is the mountainous areas, and if this goes up, okay, this climbs up little bit, then you will have change in the base level, and this change in the base level will result into the erosion. Okay. So in general terms, if you take as a stream flow downslope, its potential energy decreases and finally falls to 0 as it reaches the sea. That is your base level actually. So that the energy will be almost negligible at that point of time. Okay. So let's see the examples which I have explained how it looks like. Okay. So this figure, it shows the ocean. Okay. And the streams are getting into the, like, debouching into the ocean, and that marks your base level. So this is your base level here, which has been marked. Okay. So this is your base level. Now there are other issues also, okay, which can result into the change in the base level, or maybe because of that is man-made. Okay. And that is because of the construction of your dams. Okay. And that is what we will call as an local base level. Then another part is also there, that because other than that we have even the, if there is a volcanic eruptions, that can result into the dams, lava dam we will call it. If we have the landslides, that can also result into your dams. Now if these landforms are formed, that will also result into the change in the base level of the upstream side. So the limiting level below which a stream cannot erode. Okay. So unless and until your base level is been achieved, it will not erode. Okay. The land is called the base level of the stream. The base level are for most streams is the sea level, but in our case what we are going to see is that the ocean is not the base level, but what we have the landforms and the related. So plain will be, alluvial plain will be our base level. Okay. So we'll stop here and we'll continue in the next lecture talking more about the landforms and all that. Thank you so much. Namaskar.